Okay, hello everybody. I'm going to record myself completing the worksheet for assignment 1.9, and in doing so, show you my methodology in solving for the exposure solutions on the worksheet. And hopefully, this video will help reveal to you the correct answers. So if you missed any on your worksheet, you can compare your responses to what I'm doing here, and hopefully it'll give you some insight on the correct way to solve for that solution or that type of solution in the future. Okay, so we're going to go to assignment 1.9, and here we go. So it's fill out the empty boxes below with the camera settings that will equate to proper exposure. Use the baseline given to you as your confirmation of a correct exposure. Each line should represent a correct alternate set of solutions that also equal a correct exposure, equal to that of the baseline. The goal is to create new consistent exposures for a new set of shots that avoid under or overexposure variances from the original solution, but give you better flexibility in terms of some of these variables. Okay. So we're going to look at the helpful graphs. I have the worksheet opened up in my Acrobat Pro. So we'll look at the jump charts and we'll try to answer the questions on page 3 as well in the process. So let me switch over to the worksheet. Okay, so here we are. This is page 1 on the worksheet, and I think this is the one that gives everybody the most amount of anxiety, and I apologize for that. It's more daunting than it actually is, I think. Looks more daunting, I should say. We want to solve for these gray boxes right here, okay? So the first thing I want to do is I'm going to acknowledge that my baseline is highlighted here in mustard, and I have an example that's also highlighted here, and they stand out from the rest of the solutions numbers 2 through 9 to give us an indication of A, what the appropriate baseline exposure was for this scenario, and then it shows you an alternate set of solutions that equals the baseline. Okay, so if we had this set of exposure variables dialed into our camera, and it created a hypothetically well balanced photo. We looked at the photo or the video image, and we decided that it had a very pleasing balance between highlight and shadow. It wasn't too bright and it wasn't too dark. Then if we change something like ISO right here from the original 800 to a new ISO, say 1600, and this might happen if, let's say, you're photographing exteriors outside and your first take is done at ISO 800 and it looks okay, but you want another take for safety, or maybe the actor flubbed a line and you really think that they could do it better a second time, but the sun's going down rapidly. So you look at your image in the monitor before you reset to go again, and you realize the image is starting to look a little dark. So you might set your ISO to a higher number here to reset the balance on the monitor and make the image look good, right? So you raise it to 1600. Well, what does that mean for the exposure? Well, if the situation was too dark and you needed to brighten it up, that's fine. But let's say for some reason you have another justification for changing your ISO. What if you just want to see what would happen if you change your ISO from 800 to 1600? And if you did so, if no other factors changed, if everything else stayed the same, then that means that your aperture would have to change to accommodate this new adjustment. Okay? So we go from 800 to 1600 just arbitrarily, just to see what would happen. Well, what's going to happen is our f-stop, which was a 4, which worked well with ISO 800, is going to be too bright for ISO 1600 because we just told the camera to make itself more sensitive. Okay, and that could be for a number of reasons. In order to balance what was a 4 with an 800, we need to now make this image or this number a darker number to compensate for the brighter adjustment we made over here. So going from 800 to 1600 makes the image look brighter, right? So we may have to then go from an f4 here and close down the iris, because you can see here on the jump charts, from an f4, if we need to make the image darker, we need to jump one direction, one space this way to the left to a 5/6. And when we do that, of course, we compensate now by one f-stop darker to balance with this one f-stop brighter. 1600 is twice 800, so that represents one f-stop of adjustment, right? Let's look at the jump chart for ISO. If we go from 800 to 1600, we've made the image brighter, and we've made the chip more sensitive, okay? And since it's only one jump from 800 to 1600, in other words, double 800, that's 1600, one jump on the chart, that represents one f-stop of change. So if this is one f-stop of change, okay, and it makes the image brighter, and F4 to F5, 6 represents one f-stop of change, making the image darker, then -1 darker and +1 brighter should equal out to 0. When they equal out to 0, your exposure is well balanced. So that's why you see in this box we have a 5.6 put in here, okay, because 5.6 at 1600 is the same as 4 at 800. And everything else, as you can see, stayed the same. The frame rate stayed the same. The shutter angle or shutter speed stayed the same. The number of neutral density filters stacked into the matte box stayed the same. Okay, so the aperture had to change, and it had to change to a 5.6. One f-stop darker balances against one f-stop brighter for a net change of 0, essentially. And that means it's a good exposure, alternate set of solutions. Okay, so stuff's going to change down here now, which is going to make this a little bit more complicated. All right, and if you just take these, if you take them line by line, right, and look at them each time, I guess it could maybe get a little confusing or maybe a little daunting. So here's what I suggest you do. You go to each category that represents a factor that's going to change. ND filters, f-stops, of course, ISOs, shutter speeds. Look at this. They stay the same the whole time. All right. If that's going to be the case, then we can kind of ignore this column. And then the frame rates are going to change occasionally to something different. Okay. If the frame rates change to something different, we may have to make an exposure correction to accommodate that change. Okay. So let's take a look at the chart, and I'm going to go through the chart and I'm going to say how much rate of change has happened in this column. Okay, so from the baseline in line 1 to our first solution, the ND filters have stayed the same, right? That represents 0 change. Okay, so I'm going to put a 0 there. We need to solve for this box, so we'll leave it blank for the moment. 1/4, 1/4, ND 1/4. How much rate of change is that? Well, let's take a look at the ND chart. Let's see. If ND 1/16 represents a 4-stop addition of neutral density or a darkening of the image, stacking of filters, adding of sunglasses, however you want to think about it. If 1/16 represents 4 stops of underexposure, you see here f-stop reduction. Reduction means minus, so it's -4, right? It's a 4-stop reduction in exposure. Well, 1/4 or 1/4, look here, represents only a 2-stop reduction. So the difference between a 4-stop reduction and a 2-stop reduction is basically 2 f-stops. It's 2 jumps, 1, 2, right? And if you're going from a darker situation, 1/16, to a brighter situation, 1/4, and the difference is 2 stops, that makes this a net +2, right? So I'm going to put a +2 here next to this figure in this column. And I'm going to go down through each of these in each column, and I'm going to tell myself, what's the rate of change here? What's the rate of change here? And what's the rate of change here? And when I do that, my worksheet's going to start looking something like this, right? I have net 0 change in green. I have overexposure or brighter net change in green. I have darker changes or underexposure as minus values, and they're in red, right? And then I haven't done anything for the f-stops, so I'm going to continue my my thought process here and enter a couple of values for these solutions right here, so I can show you again what my method of thinking is. If my baseline is a 4 and I close my lens down to an 11, what have I done? Well, let's see. On the, whoops, I guess I got to go to the jump chart on the other page. Sorry about that, folks. If I start with a 4 and I go to an 11, how many jumps is that? Well, let's look. Okay, here's a 4 right here. Okay, here's an 11 over here. 4, 5, 6, 8, 11. 1, 2, 3. I've made the light going through the lens 3 f-stops darker than it originally was at a 4. So let's go back over here to our worksheet and let's put a +3 in there. And I'm going to make that number green because my other numbers are green. Whoops. And we'll go +3 right here. Okay. And then since I'm a neat freak, I'm going to move it over here to one side. Okay. Now, here's your baseline again. And in this box, nothing has changed. It's still a 4. So let's put a net zero change here. And then we know that we're not doing anything to compensate for an f-stop that hasn't changed. Okay, something else must have changed, and I see over here it's a frame rate. Same thing here. This f4 is still f4, so we'll put a 0 there as well. And we just did this up here. We know it's +3, so let's just put a +3 here. Now, we've got our worksheet all kind of matrixed out here a little bit. We know where our overexposure is, we know where our underexposure is, we know what all the differences are, and if it hasn't changed, we put a 0 there. Okay, so now we can take this worksheet and we can start working it line by line horizontally. The vertical work is done. Okay, we've measured all the rates of change. So let's go to solution number 2. No rate of change here. We need to answer for this square. This represents +2 of overexposure, no change, and +1 of overexposure. That's a net value of +3 overall, right? So if these two changes represent +3 of exposure overexposure, then this value, whatever it is, has to represent -3. So we get back to a net 0 situation, right? So if we go 3 stops from F4, what's that going to look like? Well, let's go to our jump charts over here. Here's F4. We're going to have to open our lens 3 stops, right? Or are we going to have to darken our lens 3 stops? Let's look back here and see what we got. +2, +1, total of +3. That means the image is too bright. So this value has to be darker. So it's going to be something that's going to balance out with this. And if it is, oh, I'm sorry, look what I've done here. I've made an error already. That should be a -3 because it's darker. So let's make it a -3. And the same with this guy here. This should be a -3. So our answer is already on the chart somewhere. All we got to do is remember what we did and where we did it, right? So if this is -3 and these two solutions over here are +3, we need to put an 11 right here. And I think that's pretty easy to see because we've already figured out what 11 was, kind of clumsily on my part, but we've already sort of figured out that F11 was a 3-stop reduction in exposure. So all of my answers in these gray boxes now are going to be black. So, okay, so we put an 11 here, okay? Now we've got a -3 at 11, a +2, and a +1, so it all balances out to net 0, okay? Line 3, we have to solve for a neutral density filter problem. Okay, so I went ahead and figured out what all of my stuff's doing. Oh, look, 0 rate of change, still 24 frames. This is still the same. 800 ISO, 0 rate of change. The f-stop changed to 11, which is -3, so this has to become a +3 value of some kind. So if 1/16 represents a -4 stop neutral density solution, right, then we've got to jump 3 stops brighter, or we got to take off 3 sets of sunglasses, or we got to think about it as removing 3 layers of ND from our map box. So if we take 3 jumps from 1/6, 1 over 8, 1 over 4, 1 over 2. 1, 2, 3. Okay? I think that works pretty well. So let's show you over here. The answer is 1 over 2. Right? Because this represents 3 stops brighter than it was when it was 1 over 16, right? 1 over 16 was minus 4. We have minus 3 happening here, so we got to change minus 4 to something different. Plus 3, we got to brighten it up by 3 stops. So 1 over 16, 1 over 8, 1 over 4, 1 over 2. And then all of this should balance out to a perfect exposure. Okay? Hopefully this is starting to make sense to you. Let's look at line 4. Okay. Here is a plus 2 rate of change. So we went from 1 over 16 to 1 over 8, and then from 1 over 8 to 1 over 4. That's 2 jumps brighter. 2 jumps brighter. We took off 2 pairs of sunglasses, and now we're overexposed from the baseline by 2 stops. We're going to solve for an aperture. The aperture is going to have to close now. Maybe. Probably. Look what else changed. The ISO became 1600 from 800. So that's another stop of overexposure. So now we have a total net of plus 3 overexposure, right? The shutter speed hasn't changed, but the frame rate changed to 48. Okay, if the original frame rate was 24 frames per second, and that was a perfect exposure, if we now double the frame rate, logic would say if we've doubled the speed with which the shutter is opening and closing, then that would equate to half as much light striking each frame each time the gate opens. So that's like saying it's underexposing by 1 stop, okay, for 48 frames. If that's the case, minus 1 stop and plus 1 stop, these two balance each other out. All right, so we can pay no more attention to what's happening to the right of this gray box and only look at the new net value plus 2. So this value now has to be minus 2 from the baseline in order to balance this adjustment. So if we go minus 2 from an f4, that sounds like we're going to close the lens from a 4 to something smaller so that we allow less light through. So 4, 5, 6, 5, 6, 8, 1, 2, right? F4, 1, 2, now F8. So let's put an 8 in this box right here. And that is our new f-stop based on this change and this change and that change. The net change now at f8 becomes 0. Everything balances back to 0, okay, which is the baseline. Perfect exposure. All right. Line 5. Now we want NDs again. Oh, look at this. Nothing changed with the f-stop. Nothing changed with the ISO. Nothing changed with the shutter speed. But, the frame rate went way up to 96. All right, 24 times 2 is 48. That's 1 jump. 48 times 2 is 96. That's 2 jumps. Look at that. 1, 2. Or here it is right here in this cluster of numbers. 1, 2. 1, 2. 2 stops. 2 stops darker because the frame rate got faster, not slower. If it was slower, here, look, 12 is half of 24. That's slower. That means the shutter's open longer, and it's 1 jump away from 24. That makes it a +1 overexposure, right? But in this case, it's a -2 because the frame rate became doubly fast and doubly fast again, okay? 1, 2 jumps, -2. So that means this has to be a +2 factor to balance this. So what's +2? Well, if the baseline was 1 over 16, and we have to take off 2 layers of sunglasses or 2 layers of neutral density filtration, 16 to 1 over 8, that's 1 jump. 1 over 8 to 1 over 4, that's 2 jumps, right? This becomes 1 over 4. And that's our new neutral density filter pack based on just this change to make it all balanced back to net zero and equal whatever happened here. Okay. All right. Line 6. Now we want an f-stop again. Okay. So what's it going to be? Well, our first rate of change is +1. We took off a layer of sunglasses. We took off one ND filter layer. So it's now only 1/8 from 1/16. That represents +1, one stop overexposed. The ISO stayed the same. No rate of change. No rate of change on the shutter speed, and look, no rate of change on the frame rate either. All this stayed the same as the baseline. So the only thing that changed was we took one layer of ND filtration out of the matte box, so that made it one stop brighter. If this is one stop brighter, then this value from the baseline has to become one stop darker. One stop darker from 4 means going to the left. So 4, one stop darker, smaller iris from 4 to 5/6. One jump, one f-stop. Okay? So that means 5/6 goes in this box right here. Okay? Line 7. Okay. 1/4, that's +2 from the baseline, which was 1/16. So we've got less neutral density filtration in the matte box right now. There's only 1/4 as opposed to 1/16. If we look at our list, 1/4 is a 2-stop reduction. That's also like saying optical density 0.6, which is how we refer to our cut glass filters. All right, ND4, 1/4, okay? 2-stop reduction. All right. Well, in this case, it's making our image 2 stops brighter by removing 2 layers, okay? So we can think about it either way. If we're starting from nothing and adding 1/4 ND filtration to the camera, then yes, we're making the image 2 stops darker. But when we started from 1/16 and we took 2 layers of ND filter out of the camera to get to 1/4, basically whatever this was just became 2 f-stops brighter. Okay, so that's why I put a +2 here next to the 1/4. All right, so if this is +2, oh, the aperture stayed the same. That's a net zero change. We want to know the new ISO, so that's blank. This stayed the same, 1/48, and our frame rate went to 48 frames a second, which represents one stop of underexposure. The frame rate got twice as fast, allowing half as much light to pass through per frame. That's a one-stop reduction in exposure against a 2-stop increase in exposure over here. So our net -1 plus +2 equals a net change of +1. Okay, +1. So our ISO has to get one stop brighter. Well, if we tell the camera to get more sensitive by 1 f-stop and we started at 800, look here, one jump to 1600 is 1 f-stop brighter. So this becomes ISO 1600. Okay. Hopefully this is starting to sink in. Here's solution 8, solving for ND filtration. All right, look, wow, aggressive change on the aperture. It's closed down 3 stops. This is 3 stops darker. The rate of change is 3 stops underexposed. Oh, and the ISO bumped up to 3200. That represents +2. Look at our jump charts again. 800, 1, 2. 2 stops brighter. Boom, boom. 800, 1600, 3200. It's going more sensitive to light, higher intensity, brighter exposure with 3200, right? So over here, this changed to 3200. That means it's +2. So right now we've got a net -3 and +2. If we add those together, it's a -1 situation. But oh no, we went to 96 frames over here. So it's -1 and -2 added together is a net -3 change. These two, in other words, canceled each other out right here. These two canceled each other out, and the f-stop net change of -3 now has to be adjusted over here. This value has to become 3 times brighter than it started at 1/16. So again, let's go to the chart. 1/16, 1/8, that's 1 jump. 1/4, that's 2 jumps. 1/2, that's 3 jumps, right? We go from 4 stops under exposure to only 1 stop under exposure, which is a net change of +3. So if this is -3, then our net change of +3, 1/2, is our correct ND filtration pack for the new exposure solution. Okay? And finally, we've got line 9, which is 0 net change on the ND filters. It is 0 net change on the ISO, 0 net change on the shutter speed, but a +1 net change. We've gone to fast motion, 12 frames per second on the camera for some reason. And so we're overexposing now by 1 f-stop. So we have to compensate with a -1 over here from the baseline. The baseline was a 4. If we close the lens down by 1 f-stop to make the image darker again, what's the jump chart say? 4. Close it down 1, 5, 6. Boom. That's the answer. 5, 6 here. Okay. So that's how this works, folks. It's really no more complicated than that. And once you get the hang of understanding these relationships and being able to count the jumps in your head, you no longer need the cheat sheet. But until then, I suggest printing this out and just keeping it with you whenever you go out shooting or whatever. If you want to make changes to the camera because you want a certain ISO or you want a certain f-stop, okay, and you know you have to make changes, but the changes have to be net 0, so you're not too bright or too dark when you make those variables different, bring the sheet with you and just, count the jumps on the little chart here. There's no shame in that. And eventually, with practice and time, this is going to become, second nature to you. And believe it or not, it will happen very quickly. So this becomes the set of new solutions, each one of these, okay? And each one of these has something interesting going on, okay? So there's some questions that are going to be asked on the last page of this worksheet, okay? And they very simply relate to whatever solutions you've arrived at on page 1. Which of the shot solutions will produce grainy or noisy images? Well, we know that ISO can produce grainy artifacts in the image if we go too high in exposure, right? So if we look at our worksheet and we see that our baseline was an 800 ISO, I've always said the best ISO to start with is the ISO that the manufacturer recommends in the instruction manual, which is called the native ISO. So if the native ISO of the camera is 800, that means the manufacturer has decided that this camera sensor performs best at ISO 800, meaning minimal noise, best color saturation, best contrast, and best sensitivity. All right, so if 800 for this particular camera, whatever it is, and I don't know, it's all hypothetical, but since this was the native ISO and it was 800, we can assume that that image probably wasn't very grainy. But if we change to 1600, we're adding sensitivity to the chip, which means we're boosting the voltage to the chip or driving up the gain on the sensor itself. And with each increase, we get more and more grainy. So any of the solutions that have ISO 1600 or higher, I think, are going to be the correct answers for this question. Which solutions, and it's a plural, will produce grainy noises or noisy images? And so that answer is going to be, it looks like 2, 4, 7, and 8. So we would put 2, 4, 7, and 8 over here. 2, 4, 7, and 8. Okay. Which shot solutions make use of 2 or more layers of ND filtration? Let's look. We know that 1 over 2 happens to be 2 layers of ND, right? 1 over 2, actually it's only 1 layer. It's 1 filtration layer. So that means anything more than 1 over 2, 2 layers, 2 stops, 2 layers, 1 over 8, 3 layers, 1 over 16, 4 layers. Basically anything with a 1 over 4, 1 over 8, or 1 over 16 is going to be the answer to this question. So that's 2, 4, 5, 6, 7, and 9. Basically everything but solution 3 and solution 8. So the answer is 2, 4, 5, 6, 7, and 9. Everything but 3 and 8. Which shot solutions will produce slow motion videography? Slow motion videography occurs when our frame rate becomes faster than our base frame rate. Okay? More frames per second will result in more frames being projected on playback, which has the effect of looking like the image is moving in slow motion. So, which of these solutions are running faster than 24p? Well, number 2 is not. It's running slower. 3 is normal, but 4 is technically high speed. It's twice the normal frame rate. And 96 is 3 times the normal frame rate. So here's 4, 5, 7, and 8. 4, 5, 7, and 8. Let's put some spaces in here to be neat. All right. Now, which of the shot solutions will produce fast motion videography? Motion appears to be moving faster when the frame rate slows down because there is more intermittent movement between frames that is occurring, and so the subject appears to be moving faster through space due to the lower frame rate. So there's only a couple here that are lower than 24, 12 and 9. So 12 and 9 is the answer to number 4. And then last, which shot solutions do not make use of ND filtration at all? And the answer to that is none of them, because they're all using ND filtration here. Okay, so here we can just say none, or I suppose 0 would be technically a correct answer as well. Okay, so your page 3 solutions should look like this. Okay, if they don't, it is because your page 1 solutions don't match my answer key here. Okay, and unfortunately, these are the right solutions. So if you've deviated from these, then that means you got the solution wrong. And so therefore, if you got one of these solutions wrong, you may be supplying the wrong information to these questions as well as a result of your miscalculation. So this page here sort of depends on your success on page 1. And that's just how the worksheet tumbles out. So I hope that this has been a helpful tutorial for you. If you have any questions, as always, you can reach out to me through the web courses email box, and I'll get back to you as soon as I can. But hopefully now, if you compare your worksheet to what I've done here, you'll be able to determine which answers you got wrong. This is going to help me also with the grading, because now I'll just go through and figure out whether or not your answers conform to mine. If they do, you'll get a good grade. If they don't, you'll see the representative grade here, and then you can go through and you can look for the solutions that you need to think about again or take another crack at. Okay? So best of luck to you. I'm going to begin grading those papers now this evening. So I hope this helped. I hope that that this process is a little bit more clear to you. And I hope that I made it easier by showing you how to address the rates of change amongst the variables first before you start grouping them together into matrices of alternate exposure. All right. Again, reach out to me by email if you got any questions. And I thank you for your time and attention. Have a good evening, and I'll see you all next week. Thanks so much.